In Chapter 6.1, we are studying random variables, and so we're going to look at some problems dealing with discrete random variables. The first problem is problem 41 on page 257. Put some air in your tires. So we want to let x represents the number of tires with low pressure on a randomly chosen car. The probability distribution of x is as follows. So here's the probability distribution. So the first question is find the probability that exactly one tire is found to be low on a randomly chosen car. And from the probability distribution, we can see that when x is equal to 1, the probability is just 0.2 or 20%. The next question is find the probability that more than 2 tires have low pressure on a randomly chosen car. In this particular case, more than 2 is these two numbers, 3 and 4. So we add them together. The probability of x equals 3 plus the probability of x equals 4. And we see that it is just 0.2 plus 0.1, which is 0.30 or 30%. The next question is find the probability that no tire is low on a randomly chosen car. And from our probability distribution, we see that that is 0.1. The next two questions have to do with the binomial calculation of mean and standard deviation. And in this particular case, it's not the binomial, I'm sorry. It's computing the standard deviation, and of course the mean, that is. And in this case, we multiply the probability times its value of x, and we sum them over the entire probability distribution. So in this case, mu is equal to the summation of x times p of x, right? And so this is how we calculated the mean, and we get 2 tires when we calculate it. For the standard deviation, the book shows that you can calculate the standard deviation in the following way. Sigma x is equal to the square root of the summation of each x squared times its probability of x, and then separately minus mu squared. So in this case, what we did is we squared the x values. So 0 doesn't count because 0 squared is 0 times 0.1, doesn't matter. 1, the square of 1 is 1 times 0.2. This should be 0.2, by the way. Then it's the square of 4, or the square of 2, that is, which is 4, times its probability of 0.4. The square of 3, which is 9, times 0.2, and the square of 4, which is 16, times 0.1. We add those up. We subtract 4 from it because we have to square the mean value, and then we take the square root of all that, and we get the number 1.095. That's what this is right there. Also in this section, we were looking at something called the expected value, which is nothing more than the mean value, but the expected value deals with profit and loss. So in problem 51 on page 259, the lottery, in the New York State lottery system, you pay $1 and pick a number from 000 to 999. If your number comes up, you win $500, which is a profit of $499. If you lose $1. Your probability of winning is 0.001. What is the expected value of your profit? That is, your expected gain or loss. So the solution is the expected value of x is the probability of winning times its profit minus the probability of losing times its loss. So in this case we have 0.001 times 499 minus 0.999 times $1. It gives us 50 cents loss. So you're expected to lose 50 cents each time you play the lottery. Now, in this particular case, how did you get 0.999? Well, it's 1 minus the probability of winning is the probability of losing, right? 0.999. The final problem we're going to look at is the following, where we try to create some sort of a probability distribution to some extent. So, problem 59 on page 259 and 260, a couple plan to have a girl or have children until a girl is born, but they'll have no more than 3 children. Assume that each child is equally likely to be a boy or a girl. Let the event y be the number of boys they have. Find the probability distribution for y. Find the mean number of boys in this problem. Find the standard deviation. So the solution for A is this probability distribution which we create. These are the events: boy, 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 girl, boy, girl, girl. And so y is equal to the number of boys. There is the y variable, 3, 2, 1, and 0. And then the probabilities of each event. So it's 1/2 times 1/2 times 1/2 is where you get 3 boys. And that happens 1/8 of the time. If you get 2 boys and a girl, it happens 1/8 of a time. If you get just a boy and a girl, that happens 1/4 of the time. And then if you get just a girl, it's just 1/2. So if we want to find the mean number of boys, we use the formula. We multiply the value of y times its probability, and you can see we come up with 7/8, which is 0.875 of a boy, which is approximately 1 boy. And then when we did the standard deviation calculation, we get the standard deviation of 1 boy, right, which is I can go 1 standard deviation below or 1 standard deviation above, right? So that's the way to do this particular problem. That concludes our look at random variables in chapter 6.1, and then we'll be starting chapter 6.2 the following time.